Our next lesson will be on the chain rule, again applying all of our derivative information. However, with this chain rule, this is going to be whenever we are having to find the derivative of a composite function. And a composite function just means we have one function plugged into another function. And they've given us a good example here. Now the notation for the chain rule, notice after we have our composite function f composite g, or f of g of x, then we have the derivative of the outer function f prime times the derivative of the inner function. And if we'll remember that pattern, that's going to make it pretty easy for us. And even the author of these lessons, they also told you. Notice they have multiply the derivative of the inside of the function by the derivative of the outside of the function. And that should help us remember how to do these problems. We are still, so for example 1, they're showing us that there's two different ways we can do some of the problems, because they do overlap, some of them with chain rule and some of them without. So for A, if we do f of x without the chain rule, we would need to FOIL this out. And when we do, we would have 25x squared plus 30x plus 9. And then we would do our f prime at x, and that's going to be 50x plus 30. Now that's without the chain rule. That's going through all of the algebra. But with the chain rule, it's going to save us some of the algebra. So f prime at x, that's going to be the derivative of the outside. So in other words, we're going to do a derivative outside, 2 times 5x plus 3, all raised to the first, times the derivative of the inside. And the derivative of the inside is just 5. And we can leave it just like that, or we can simplify and multiply the 5 and the 2. So we have 10 times 5x plus 3. So if you notice, we really end up with the same exact answer for both. Usually when the exponent's a 2, it's about the same to do both either way. But now when we look at example 2, we have something raised to the third power, and this is where you're going to really want to incorporate the chain rule. And so let's go ahead and do that for this one. We would have f prime of x equals the derivative of the outside of the function. So here we're going to multiply that 3 down and subtract 1. So we're going to have 3 times 4 minus x squared, all raised to the second power, times the derivative of the inside portion. Well, the derivative of the inside portion is going to be negative 2x. And then finally, this last step, they usually multiply these coefficients together. So it looks like we're going to have negative 6x times 4 minus x squared, all squared. Okay, let's practice on a few more examples. For A, we would have to do some rewriting here. So we do see that we're going to have f at x equals, and this is going to be x squared minus 1, and it's going to be your exponent over your root, so that's going to be to the 3/2 power. Now we're ready for the derivative, and we will do the derivative of the outside. So we're going to have 3/2 times x squared minus 1 raised to the positive 1/2, and then times the derivative of the inside. And again, the simplifying, if you want to, you can multiply those coefficients. So f prime at x is going to be 3x times x squared minus 1, all raised to the 1/2. Part B, we can flip this over and make this -7 the coefficient. So if we rewrite it, we're going to have f of x equals negative 7 times 2x minus 3, all raised to the negative 2. Now let's do our chain rule. So we're going to do the derivative of the outside first. And when we do that, we're going to have positive 14 times 2x minus 3 to the negative 3. And then times the derivative of the inside, which is 2. And we're welcome to leave it like that, or our multiple choice would probably have 28 times 2x minus 3, all raised to the negative 3. Our next example, again, we need to do the derivative of the outside first. So we're going to have 2/3 times 5 minus 4x squared raised to the 2/3 minus 1, so negative 1/3. We've done the derivative of the outside times, and if we do the derivative of the inside, we have 8x. Alright, and the same over here for D. We're doing the derivative of e to the x, and this is where we talked about the derivative of stuff prime, or a derivative of e to the stuff. So we're going to review that. That's going to be equal to the derivative of the stuff, or stuff prime, times e to the stuff. So with this, the stuff is always going to be that exponent. So we have y prime equals the derivative of the exponent, which is going to be 6x, times your original function, e to the 3x squared. So again, here's your stuff prime, and here's e to the stuff. Okay, continuing on, we would need to rewrite e. So we're going to rewrite that to be y equals negative 2, and then we're going to have 6x plus 3, and that's all going to be raised to the negative 1/3. So now we're ready for y prime, which is going to end up giving us 2/3 times 6x plus 3 to the negative 4/3, and then times the derivative of the inside, which is just 6. Okay, part F, same idea here. Now we have to do some rewriting with this because they really gave us some interesting stuff. This 3 that's on cosine, we're going to rewrite this and move that to the outside. So we're going to have cosine of e to the 5 theta, and then all of that's raised to the 3rd power. That 3 gets moved to the outside. So now we're ready to do our chain rule. We are going to do the derivative of the outside first. So all of that just gets rewritten to the 2nd power. But now we have to do the derivative of the inside. So the derivative of sine of e to the 5 theta is going to be negative sine of e to the 5 theta. And then we still have one more thing we have to take the derivative of, and that's going to be the derivative of e to the 5 theta, which is just like the previous problem, it's e to the stuff. So we need the derivative of our angle first, which is going to be, or derivative of the exponent, which is going to be 5, and then we're going to have that times e to the 5 theta. All of that's going to be our derivative. So again, we moved our exponent 3 to the outside. We do our outer derivative first. Then the inner derivative, the derivative of cosine of e to the 5 theta is negative sine e to the 5 theta. But then we have to also take the derivative of that angle. All right, let's try another one. Okay, now in part G, we will do our natural log. And with the derivative of the natural log of stuff, let's talk about that, review it for just a moment. So the derivative of natural log of stuff, we said that derivative was equal to the derivative of stuff, which is stuff prime, all over stuff. Alright, so let's apply all of that over here. So here we're going to have, we've got an exponent, and let's go ahead and move that exponent down to the front. That's one of those properties of logarithms, and that's just going to make this problem easier for us. So we're going to have 2 times natural log of x squared plus x plus 1. And now we're ready for f prime at x. So that 2 is just going to sit out there. And remember, we're all of this part of the angle, that is our stuff. So stuff prime, so we're going to have 2x plus 1 all over stuff again. So that's going to be our x squared plus x plus 1. And that's going to be it. So it does help moving that exponent down to the front. Alright, so for this one, this is where we're going to use some of those nice little values of e that we wrote down the other day. So let's do some rewriting with that. So here we're going to say f of x equals x squared. Now this negative 4 right here, just like we moved the exponent down to the front, we can move it back up. And so when we do that, notice we're going to have e to the natural log of x to the negative 4. And then all of that's going to reduce down to be just x to the negative 4, because natural log, or e to the natural log of x is just x again. So this is just going to be x to the negative 4. And notice this problem really ended up being more algebra than anything. In the rewriting, we have x to the negative 2. So when we're ready for f prime, it's going to be negative 2 x to the negative 3. And you are finished. Okay, looking at the next example, we do have our trig functions with our exponents on them. So we need to go ahead and do some rewriting with this. So we have g of x equals, and this is going to be cosine of 4x all squared minus sine of 4x all squared. And now we're ready to do our derivative, and we need to do the derivative of the outside. So it's going to be 2 times cosine 4x to the first, but then it's also times the derivative of the inside, which is going to be sine of 4x, and then times the derivative of 4x, which is 4. So there's going to be just the derivative of that first part, minus, and now we're ready for the derivative of the second part. And I'm going to change colors to help us keep up with that. So then that's going to be 2. We have to do the derivative of the outside first. And then we're going to do the derivative of the inside. So that's going to be cosine 4x times the derivative of 4x, which is 4. Alright, and it looks like going back through, I need to put a negative there. So that's going to be the derivative of cosine is negative sine. Alright, so moving on to our next problem. We have the natural log of the natural log. So that's kind of terrible looking, but again, we still have the derivative of our stuff over stuff prime. So let's see what we're going to end up with this. We have h prime of x equals, so we need the derivative of stuff, which is going to be 1 over x back over stuff, natural log of x, and then that, or you would see it as 1 over x times natural log of x. Sometimes you'll see that rewritten. The reason why that's the case, do keep in mind this portion right here, that's all multiplication or division, so you have 1 over x divided by natural log of x, and this is where we would do our keep, change, and flip. So we keep 1 over x, change our division to multiplication, and flip our second. So that's why you are able to simplify that. Okay, so for this next one, it looks like we're going to have some product rule mixed in with chain rule. We do need to rewrite this, so we're going to have x to the fourth and then times, and I'm going to move that exponent of 2 to the outside. And so now we're ready for y prime, which is going to be the first times the derivative of the second. So the derivative of the second is where we're going to have our chain rule. We're going to do the derivative of the outside portion and then times the derivative of the inside. And then we would do the derivative of x, which is still just 1. That's why we've not had to write it before, and you don't have to write it now. Okay, so we have first derivative of the second, and then plus the second, which is sine squared x, times the derivative of the first, which is going to be 4x cubed. And you are finished. Okay, now for the tangent, notice our angle. We do need to rewrite that, but when we do our exponent here, that exponent's on the angle, not the trig function. So we're not going to do rewriting and moving all of that out. Now we do need to do our derivative, and that's derivative of tangent is going to be secant squared of our angle, so 2x minus 3 all raised to the 1/2, but then that is also times the derivative of this portion, and that's going to be where the chain rule pops up. So this is going to be the derivative of the outside, which is going to be 1/2 times 2x minus 3 to the negative 1/2, and then times the derivative of the inside, which is 2. And yes, please, please, please just leave your answer unsimplified. All right, so for m, again, I would move this exponent to the outside. So I have g at theta equals, and that's going to be 4 times cosine of pi theta, all of that raised to the second power. So g prime at theta is going to be, and again, derivative of the outside, so that 2 is going to be multiplied down, so that's going to give us 8 times cosine of pi theta, all raised to the first, then times the derivative of the inside, which is going to be negative sine pi theta, times the derivative of the angle. The derivative of pi theta is just going to be pi. And then that's going to be it for that derivative. Okay, same idea here. So f prime at x, the derivative of sine would be cosine of our angle e pi to the x. But then we have to also multiply times the derivative of the angle. Derivative of e to the x, well, is still e to the x, but I've got a coefficient of pi, so we need to do the derivative of our exponent, which is going to be just pi, and then back to e to the pi x. So that's going to be our stuff prime times e to the stuff. Alright, so for now our next example, let's see what it's going to ask us to do. We're told that function f is continuous and differentiable over an interval from 0 to 1, and we have that g of x, very importantly, we're told that g of x is equal to f of 4x. The tables below gives us values for f prime. Okay, so we want to know, well, what is the derivative value of g prime at 0.2? So we really need to go find first, well, what in the world's the derivative of g of x? Well, remember that g of x, they just told us, is equal to f of 4x. And this notation is going to imply the chain rule again. This is chain rule. And we know that because of the 4 being on the inside part of the function. So when we go through doing our derivative, what we need to be able to do here is the chain rule. So g prime at x, again, derivative of the outside, that's just going to be f prime prime of 4x times the derivative of the inside, which the derivative of 4x is 4. Now I want to see, well, what is g prime at 0.2? Well, that's going to be f prime of 4 times 0.2 and then times 4. So let's see, if we multiply out 4 times 0.2, we're going to get 0.8. And notice that up in our chart, what is the value of f at 0.8? So that's going to give us 1.125, and then that is times 4. And y'all can either finish multiplying that out or leave it just like that. Okay, for the next examples, we are back to writing the equation of a tangent line. And notice that they've given us an x value. And so let's go through. We're going to have to find a couple of things. Remember, the formula for this is y minus y1 equals m times x minus x1. This is going to be our x1, so we can go ahead and find our y value. That's going to be h at -1. Remember, we do sub in our x value to get the y value, and that's equal to 3 f at -1 times g at -1. All right, so let's go read our chart. We have 3 times f at -1 is -2 times g at -1 is -3. So it looks like we're going to have positive 18 for our y value. So we now know that y value. Okay, now we need to go find h prime at x so we can find our slope. So h prime at x, here we're going to do our product rule. So 3f of x, we have our first, times the derivative of the second, plus our second, and then the derivative of the first, so that's going to be 3f prime at x. Alright, now let's go find our values because we do need to sub in for 1. So h prime at 1, we're going to have 3 times f at, -1, 3 times -2 times g prime at -1. G prime at -1 is 2, plus g at 2, or g at 1, sorry, is going to be -3 times 3, that was given already, and then f prime at -1. So f prime at -1 is -4. So here, finishing out the problem, we have a -4 times 3, so -12, plus, and over here we have positive 12 times 3, so 36. So our slope value here looks like it's going to be 24. So our equation of our line, looks like we're out of room, is going to be, we have y minus 18 equals our slope times x minus a -1. So there's the equation of our tangent line. Right, moving on, let's look at our other problem. Same process again. So we're told that f of x equals g times cosine of x. What is the value of k prime at 0? So let's see. Looking at that, I think she probably meant for f prime at 0. We're going to change that to that assumption there. Alright, so let's do our derivative. So f prime at x is going to be our first times the derivative of the second, so negative sine x times the derivative of x, which is just 1, and then plus our second, so cosine of x times the derivative of the first, so g prime at x. Alright, now let's go find f prime at 0. We're going to sub in our 0. And so, let's see, g at 0 is going to be -3 So we have negative 3 times, well, the sine at 0 is 0, so that's going to be useful, plus cosine at 0 is going to be 1 times, and then g prime at 0 is negative 3. So here we found our slope of our tangent line at 0 is going to be negative 3. Alright, now we need to also find our y value. We have our x value, so our y value with this, we need to find f at 0, which is going to be g at 0 times cosine at 0. Well, cosine at 0 is 1, so I'm going to go ahead and write that in. And then g at 0 is 2. So we found our derivative value here, or our y value is going to be 2 times 1, or 2. So now we're ready to go ahead and write the equation of our tangent line. We have y minus 2 equals our slope times x minus 0. And you can leave it like that, or you can go ahead and say negative 3x if you want. Either would be correct.